All right, this is section 9.6 day one, and we're going to start talking about polar coordinates, which is just another way really to measure locations. You are used to the rectangular coordinate system, which is like an X and a Y, how far over and how far up. And that doesn't always work for every situation. When you think about helicopters, they need to fly directly to a location. So they would take off, let's just say, from the hospital, and they need to fly directly to an accident, where ambulances need to follow the streets to get there. So the way that we tell coordinates can be different. Polar coordinates is one way to do that. So while your rectangular coordinates, what you are used to, are an X and a Y, polar coordinates have an R and a theta. So they have both a magnitude, which is also the same as the distance, and they have a direction, which we would call an angle. So when the helicopter takes off, if you're in the dispatch, you have to tell it how many miles it's flying and in what direction. So 5 miles at 60 degrees. Okay. So we're going to use the map to name the location with each pair of coordinates, and then we're going to give some polar coordinates. We're going to practice it both ways. So when you see a picture like this, the angle measures that we're putting on there, the lines we're putting on there, are designed to help you kind of divide the quadrants. So straight up would be 90 degrees, and then since this is chopped into 3 total pieces, this would be like the 30 and the 60. Some graphs that you use might have just one diagonal up the middle, so that would be like the 45-degree angle line. So you just have to look at what you get in the picture in terms of like dividing it up. So at 3 miles, feet, whatever, and then 120 degrees, so we're at the 3rd ring out. So 1 ring, 2 rings, 3 rings. And looking around, A is really my only option, but also that matches 120 degrees from 0. So there was 90, and then I'm 30 degrees past that. So that would be A. Next up, I've got 2 and then 315. So 2nd ring out, I've actually got 2 options, either E or C. 315 degrees would be on like that 45-degree line if I fill that in. So this one is C. Next one says give polar coordinates for the following locations. So B is right here. It's on the 1, 2, 3, 4th ring out. So we'll start with a 4. And then since it's on that line going left, that's at 180 degrees. D is right here. We kind of talked about how that's already the 60-degree angle. So that's 1, 2, 3, 4, 5 rings out at 60 degrees. And when we're working with polar coordinates, angles don't have to be between 0 and 360, just like they didn't have to when we were doing like unit circle stuff. So angles can also be named using, those are kind of, sorry. What I mean to say was this is radians, but they can also be negative. Those 2 sentences really didn't follow each other. So name the point given by each pair of coordinates. So just doing some more different ways to name stuff. So 4 rings out at negative 3 pi over 4. So this would be negative 135 degrees, or the same as positive 225 degrees. So 4th ring out, 1, 2, 3, 4, and I need a negative 135 or 225, so that would be F. 2 rings out at 390, so that's just over 360, so it's more than 1 loop around the circle. So subtract 360 off of there to find out that this is a 30-degree angle. So we're looking at the 2nd ring, 30 degrees, that would be E. Name 2 other ways to locate point C. So here's point C, and we did one of them. That was 2 and 315. We could do 2 and negative 45. That would be an identical angle. We could also do 2 and negative pi over 4. That would also work. So there's lots of ways to name these angles to get you to land at the same location. So now we're going to talk about how do you convert between the 2. We have rectangular, x, y. This is what you've grown up with. And now we have polar, so r and theta. And we need to be able to convert between the 2, kind of like having feet and inches or meters and centimeters. We have to be able to convert. So kind of going back to our right triangle, here's our angle, here's our 90. X goes over, y goes up, and we have r on our hypotenuse. So in order to go over x and up y, that's your rectangular. And then if the helicopter takes off here, you're going to tell it so many miles, that's your radius, and at what angle, so that is your r theta. So they have to get you to the same location. They're just a different way to measure. So cosine is actually adjacent over hypotenuse, x over r. We've done this in the past when we did the unit circle. And then I'm just going to solve this for x. So I'm just going to multiply both sides by r. So x would be r cosine theta. That is going to be one of our key converting formulas. Next up, I've got sine. Sine is opposite over hypotenuse, so y over r. Oops, that was not a very good y. Again, multiply both sides by r, and so y is going to be r sine theta. Tangent is y over x. That by itself is one of our converting formulas. I'll just circle the big ones. And then your last one, r squared, is actually equal to x squared plus y squared. It's kind of like, I shouldn't say kind of, it is Pythagorean's theorem. Usually we put a c where the r is, so a squared, b squared, c squared. Just as long as that one's your hypotenuse, and then your a and your b, or your x and your y, are your two sides of your triangle. So those are like your four big converting type equations. You have two of them set up right away to help you convert from polar to rectangular. So to convert from polar to rectangular, remember you're moving from an r and a theta, and you're moving to an x and a y. So you're going to do r cosine theta, because that will give you x, and then you're going to do r sine theta, and that will give you y. Just grab my calculator because we're going to do a couple right here. So the first one is 3882. This is a polar coordinate because I have an angle measure in the second spot. So this is an r and a theta. So we will do 38 cosine 82, and we'll do 38 sine 82. And literally we're just going to plug it in. So make sure your calculator is in degree mode. So 38 cos 82. Looks like I've got about 5.29, and then 38 sine 82. Looks like we've got about 37.63. And then you kind of want to graph them and make sure that what you did makes sense. So let's just get a look at this. Let's just say we were 38 rings out on our circle. So imagine a circle, it's got 38 rings out. So really big circle. At 82 degrees, that is almost vertical. 82 degrees to 90. So it's like that. Does it make sense that I could have gone over 5 and then up 37 to get there? And that totally matches. So that length doesn't tell us a whole lot. It's the 82 that tells us how far, or the angle anyway. And then these two are like your x and your y, telling you how far over and how far up to get to that place. Let's do another one. I got 2 and then pi. This is still an angle. So you are still with an r and a theta. You are in polar coordinates and you are converting. So you're going to do 2 cosine pi and then 2 sine pi. So I'm just going to type those in. 2 cosine pi. And this is a pi, which is a radian. So make sure that you switch over to radian mode. So this will be -2. And then you have 2 sine pi and 0. Let's plot this and see if that's true. So they're talking 2 circles out at 180 degrees. That'll be right there. Is that the same as -2, 0 as a point? Yes, it is. So this is the rectangular coordinate for that polar coordinate. Couple more. Sometimes when kids see the square root of 3, they immediately think that that's a radian. Remember, that is just a number. So square root of 3 is just some decimal. What you're focused on is the second location. If the second location is an angle, which this one is, then we are doing r cosine theta, oops, I almost wrote an r, sine theta. This is what we're typing in. Pi over 6 is an angle measure, is a radian measure. You could switch it to degrees if you want, just depends on what mode you want your calculator to be in. Since I just did radians, I'm just going to stay in radians. So square root of 3 cosine and then pi over 6. Looks like I've got 1.5. And then exact same thing, only we're going to change that out for a sine. And looks like I get 0.866. Let's just make sure that that's right. Square root of 3 is the rings out. Pi over 6 is like 30 degrees, so it's like right there. Does it make sense that I might have went over 1.5 and up 0.86? Sure does. Matches the picture. Last one for this particular section before we move into converting the other way. I've got 2.5, 53.1. I can see the degree sign, so that is an angle, which means we are in polar. So we're going to do r cosine theta and r sine theta. So 2.5 cosine 53.1. Remember to switch back to degree mode because this is a degree. Looks like I got about 1.5. And then same thing, just with the sine value. Looks like I'm at about 2. So I got 2.5 rings out, about there, and then I'm at 53 degrees, which is about there. Does it make sense that I went over 1.5 and then up 2? Sure does. Totally matches where we're at. Last one, we need to talk about converting the other way. So what if we convert from rectangular to polar? So this is an X and a Y. That position is not an angle of any kind. So this is like good old fashioned if I asked you to plot that point. So we're going to plot it. It's going to be negative 3 sevenths. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We're right about there. So this is negative 3. This is negative 7. And what we're talking about is sending a helicopter to that same location, but I can't use those coordinates. This doesn't make sense to the helicopter. It's not going to follow 3 streets left and then 7 streets down south. It just wants to know how far do I have to fly and at what angle do I need to fly. So first we need to know how far that is. We can do that because that's Pythagorean's theorem. So I'm going to do my 3 squared plus my negative 7 squared, and I've got 58. And you can do the actual square root of 58, like you can get the 7.6. I am okay with square root of 58. That's your first number in your polar coordinates. So this was rectangular, we are going to polar. Now I need to know that angle measure that they're using. So we're going to tan inverse, because you have a y and an x value. So we're going to do tan inverse of negative 7 over negative 3. And I get about 66 degrees. This is where you're really going to have to watch your calculator. Anytime we use these inverses, it seems our calculator is trying to lie to us. So this for sure is 66.8 degrees, but 66 degrees would be in the first quadrant, not at all where my accident is that I'm trying to send my helicopter. So you just sent the helicopter the wrong way. So you have to make sure that you are matching whatever your calculator gives you to the correct quadrant. Since we are on the exact opposite side from 66 degrees, I'm just going to add 180 because that'll go halfway around the circle for me. So this is going to be 246.8 degrees. So this is for the ambulance. It's going to go 3 streets to the left, 7 streets south. The helicopter is going to go about 7.6 miles at an angle of 246.8 degrees. And that is how you convert between polar and rectangular coordinates.